Hello, my dear mechanical marvels. How are you all? What's up? कैसे हैं सब लोग? Please, guys, do join me fast. And those who are already present in the session, please let me know through the comment section if I am audible and visible to everyone. This is Chandra Shekhar welcoming you all to the India's largest, the best, and your favorite live learning platform. That is Byjus Exam Prep. And I would like to welcome you all to the GATE Rankers Monsoon Free course, which is running on the YouTube channel free of cost for all the GATE 2023 aspirants. So those who are aspiring for getting a good rank in GATE examination, this course is running or is important for all those aspirants. How many of you are looking forward to get a good rank in GATE? The only way to get a good rank in GATE examination is by practicing more and more numericals. The more you practice, the more confident you become in the fundamentals, and the better will be the chances of getting the good rank in GATE. And that is why this course is designed in such a manner that we are practicing the numericals, and with the numerical practice only we are going to discuss the related concept. We are going to revise the related concepts over here. So today's topic, as you all know, that today's topic is convection mode of heat transfer in the heat transfer subject. What do you understand by convection mode of heat transfer? What is convection? When do we have convection mode of heat transfer? I hope everyone is comfortable with the basic concept about convection. Convection is the connection between heat transfer and fluid mechanics. Without understanding the fluid mechanics, you cannot understand the convection mode of heat transfer, because the convection is taking place in the fluid which is having the relative motion between the particles, right? Yes, Sachin, good evening. Welcome, namaskar, adab, shubh sandhya, good evening, sat sri akal, assalamu alaikum. Please do join me fast, and please share the link of this session to everyone else in your friend circle so that more and more students can join me and get benefited. So convection, that is why the topic is very important for GATE examination, because a single question can check your understanding about the fluid mechanics, as well as the same question can check your understanding about the concept of heat transfer. That makes the topic very important. It is connection, it is the combination of two subjects. One is the fluid mechanics and another is the heat transfer. There are two types of convection mode. The convection can be divided into two parts. Convection is all about the fluid motion, and if the fluid motion is created by using some external source, then it is known as forced convection. What are the parameters responsible for forced convection? Anybody having any idea? The parameters responsible for forced convection are: one is the pressure gradient. By using an external source, there is a pressure gradient develops, and due to the pressure gradient, there is an inertia force which drives the fluid flow. So pressure gradient and inertia force are the responsible factors for forced convection. What is natural convection? When the fluid motion is created on its own without any external source. That is known as free convection or natural convection. Can you guys give me an example of natural convection? Can you give me an example of natural convection as well as forced convection? So the parameters responsible for natural convection are: one is density gradient. Due to temperature gradient, there is a density gradient in the fluid, and because of the density gradient, the buoyant force is driving the fluid motion. So density gradient and the buoyant force are responsible for fluid motion in case of natural or free convection. All right, everyone please respond through the comment section. I want everyone to take part in the discussion. Whatever you know, please let me know through the comment section. Share your knowledge, and if you have anything to ask, you can use the comment section for writing your doubts as well. This is my quick introduction for those who are meeting me for the first time. My name is Chandra Shekhar. I am a mechanical engineering graduate from IIT Delhi and also engineering services examination qualified. worked in sale for a couple of years, and from last 10 plus years, I am completely into teaching, guiding the students who are preparing for various competitive examinations. And about my subjects of interest, I am quite comfortable in fluid mechanics, heat transfer, thermal and industrial engineering. So if anybody is having any doubt in any of the mentioned subjects, you can always approach me through the mail ID which is there on the screen, or you can join me on the Telegram, that is Mechanical by Chandra Shekhar, and the link is also mentioned over the screen. Once you become part of my Telegram group, then you will be getting an advantage of all these things. Forced convection means flow in a pipe. Whenever the fluid is flowing, that is an example of forced convection. Flow in a pipe, flow over a surface, wind blowing is an example of forced convection. Natural convection, if you heat water in a container, if the water is not flowing, if you heat water in a container, that is an example of natural convection. So the cooling of the electronic devices is an example of natural convection. When there is no flow, or quenching process, you must have studied quenching process in this production engineering. Quenching process is an example of natural or free convection. All right, Sachin. So you guys are watching me live through the GATE Rankers Monsoon series. Those who are not following this series, please do subscribe our Byjus YouTube channel. Then you will be getting the notification of all the classes which are under the umbrella of Monsoon series. All right. So the link is in the description box of this session. And one more important note before starting the session, please keep your pen, notebook and calculator, because you are supposed to solve the questions. I will just assist you. I will just help you out to understand the question, to understand the concept, required concept, but the final outcome will be done by you. All right. So on 24th of July, there is going to be an scholarship test for all the aspirants of GATE who want to enroll themselves in our paid courses. This is a golden opportunity. Based on your score in the scholarship test, you will be able to avail the scholarship in our paid courses. So the registration is completely free, and the syllabus for this scholarship test is the GATE syllabus only. So it will definitely help you in two ways. One is you will be competing with your competitors. So you will understand where do you exactly stand among your competitors, and other advantage is that based on your score in the scholarship test, you will be able to avail the discount accordingly. All right. Yes, hosteler, you can purchase the course. You can contact the team, Byjus team. Do you have the contact number of the concerned person? You can join me on the Telegram and you just let me know through the Telegram group. I will share the related information to you, or I will share your name. I suggest your name to the concerned authority. All right. So ready for the questions? Practice from the convection. There is the first question on the screen. Read the question carefully and try to find the answer. Try to solve it. So let us start solving the first question. Air at 20 degrees Celsius is flowing. Whenever there is a flow, it is an example of forced convection. First of all, you need to understand whether it is free or forced convection. Forced convection, whenever there is a fluid flowing, because in case of free or natural convection, we do not use the word flow. We use the motion, fluid motion. There is a difference between fluid motion and fluid flow. Flow means having a velocity. Motion means the velocity is very small, negligibly small. The air at 20 degrees Celsius is flowing over a flat plate which is 200 mm wide and 500 mm long. So width is 200 mm given, and the length is 500 millimeter given. The plate is maintained at 100 degrees Celsius. So TS surface temperature is 100 degrees Celsius and the fluid temperature. It is an external flow because it is flowing over a plate, over a flat plate. So it is external flow. The flow can be divided into two parts. One is internal, when the fluid is flowing in a pipe, that is internal flow. And when the fluid is flowing over a surface, that is example of external flow. So the free stream temperature of the fluid is 20 degrees Celsius. These are the given parameters I am writing. Find the ratio of rate of heat loss from the plate when the air is flowing parallel to 500 mm side, when the air is flowing parallel to the length, that is, let us say Q1, and when air is flowing parallel to the width, that is Q2. So we need to find out the ratio of Q1 by Q2, isn't it? Q1 is when the air is flowing parallel to the length of the plate, and the another case is when air is flowing parallel to the width of the plate. Then we need to find out the ratio of heat transfer rate. This is the question. The velocity is constant, U infinity is constant, that is 2 meters per second for both. U infinity, the velocity is U infinity. The properties of air at 60 degrees Celsius. What is 60 degrees Celsius? This is called as the film temperature. What is 60 degrees Celsius? That is Ts plus T infinity by 2. All the fluid properties are used at the film temperature. Hi Subhadeep, good evening, welcome. Welcome to the session. Please do try the question. Try to understand. The first step is, please do understand the question. Write all the given parameter in one place and also try to find out the unknown parameters. And then apply the related concept to get the unknown. This is how the steps of solving the question will work. If there is a diagram, please draw the diagram as well. So without understanding the question, you will not be able to solve it. The properties of air at the film temperature, 60 degrees Celsius is the film temperature, which is the mean of surface temperature and bulk temperature of the fluid. Kinematic viscosity is given as 18.97, thermal conductivity is 0.025, thermal conductivity of the fluid, and Prandtl number is 0.7. Right? So how to solve it? Q is given by H into the area, surface area in contact with the fluid, into delta T. That is how we can find out. That is the formula for convection. Right? Now, because the area will remain same, whether the flow is parallel to the length or the flow is parallel to the width, area of the plate will remain same, that is B into L. That remains constant. In both the situation, area will remain constant and delta T is also same. What is delta T? That is equal to Ts minus T infinity, that is 100 minus 20, 80 degrees Celsius. So As and delta T both are constant. So we can say Q will be proportional to H. So what we can say, Q will be proportional to H. Now the objective is to find the relation between H and L. It can be L, it can be width. So our objective is to develop a relation between H and L. Once the length of the plate is 500 mm, what will be the rate of heat transfer? And once the length of the plate becomes 200 mm, then what will be the heat transfer rate? That is how the question will be solved. First of all, can you just let me know whether the flow over the plate is laminar or turbulent? Can you find out whether the flow is laminar or turbulent? How to find out whether the flow is laminar or turbulent? How to calculate the Reynolds number based on the length of the plate? Rho into U infinity into L by mu. We need to check whether the flow is laminar or turbulent, or U infinity into L by kinematic viscosity. U infinity is 2, L is 500 mm, 0.5 upon kinematic viscosity is given, that is 18.97 into 10 to the power minus 6. 18.97 into 10 to the power minus 6. What is the value of Reynolds number? Even if you take 0.2 in place of 0.5, it will be less than this value. So the maximum value of Reynolds number can be, what is the maximum value of Reynolds number? Are you guys getting, what is the Reynolds number? Are you guys getting 5.27 into 10 to the power 4? Please do let me know whether you are getting the Reynolds number to be 5.27 into 10 to the power 4 or not. Which is less than, yes, which is less than 5 into 10 to the power 5. So that is laminar. The flow is laminar. The flow will be laminar because it is less than 5 into 10 to the power 5. Now, what we can do is, yes. So, for laminar flow over a flat plate, Nusselt number, that is H into L by K F, is proportional to Reynolds number to the power 1 by 2 into Prandtl number to the power 1 by 3. Isn't it? Prandtl number is constant, so we can say H into L. Thermal conductivity of the fluid is also constant. H into L is proportional to Reynolds number contains L. So L to the power 1 by 2. So from here, H is proportional to L to the power minus 1 by 2. That is the relationship. Once we develop the relation between H and L, then we can write Q1 by Q2, that is equal to H1 by H2, that is equal to under root of L2 by L1. What is L2? L2 is width, and what is L1? L1 is equal to length. So it will be 200 divided by 500. That is the ratio of Q1 by Q2, isn't it? Under root of 200 by 500. What is the answer? Is this clear to all of you or not? So the correct answer is 0.63. Option A is the right answer. 0.632. Yes, Bhavya, well done. Keep it up. What about others? Are you guys getting the answer or not? If the flow would have been turbulent, turbulent flow over a flat plate, when the Reynolds number would have been greater than 5 into 10 to the power 5, then Nusselt number, that is H into L by Kf, would have been proportional to Reynolds number to the power 4 by 5 into Prandtl number to the power 1 by 3. In that case, H into L would have been proportional to L to the power 4 by 5, and H is proportional to L to the power minus 1 by 5. If it would have been turbulent flow, then H and L would have been related in this manner. For the turbulent flow, these formula you need to remember for turbulent flow over a flat plate and the laminar flow over a flat plate. This is the formula for laminar flow over a flat. Right? The next question on the screen. Air stream at 24 degrees Celsius is flowing at 0.4 meter per second across a 100 watt bulb at 130 degrees Celsius. So the surface temperature is given as 130 degrees Celsius. It is also forced convection. It is flowing, so forced convection, and it is flowing across the bulb. So it is external flow. The bulb is approximated by a 65 mm diameter sphere. Calculate the percentage of power loss due to convection. Nusselt number for flow of gases over a sphere is given by this expression. This is the expression we are supposed to use. There is no Prandtl number here. It is the flow over a sphere, external flow over a sphere. Now what we need to do is T infinity is 24 degrees Celsius. Now we need to find out the Reynolds number. First of all, Reynolds number is Q infinity into D by kinematic viscosity. What is the value of Reynolds number? The velocity is 0.4. U infinity is equal to 0.4 meter per second. 0.4 into diameter is 65 mm. 0.065 divided by kinematic viscosity is given. This is the kinematic viscosity of the air, 2.0 0.08 into 10 to the power minus 5. All the parameter must be in SI unit. What is the value of Reynolds number? What is the Reynolds number? Based on diameter, because it is a sphere. The fluid is flowing over the sphere like this. It is 1250. The Reynolds number is coming out to be 1250. Now, once we get the Reynolds number, then find out the Nusselt number. Nusselt number can be written as, what we can write? Nusselt number is equal to H into D by Kf is equal to 0.37 into 1250 to the power 0.6. So from here we can find out the value of H, convective heat transfer coefficient. Can you find out the value of H? Sachin, what is that? 1250 will be the value of Reynolds number. Do not put the parameter in any other unit but SI unit. All the parameters should be used in SI unit. What is H? Are you getting 12.32? Bhavya, what is that? H will be equal to 12.32. Yes. 12.32 watt per meter square Kelvin. Use all the parameters in their SI unit. Once you get H, then we are ready to write the equation for convection. That is Newton's law of cooling. Q is equal to H into surface area in contact with air. That is, for a sphere, it is 4 pi r square into delta T. Delta T is equal to Ts minus T infinity. That will give you the heat loss. Q convection, heat loss due to convection, is 12.32 into 4 pi into r square. It will be 0.065 by 2 square into delta T. What is delta T? Into delta T. Delta T is 130 minus 24. 130 minus 20. What is Q convection? Are you getting 17.33? So Q convection will come out to be 17.33 watt. Please do let me know if you are getting these values or not. 17.33 watt. And what is the power of the bulb? That is 100 watt. It is 100 watt bulb. So the power lost, this is the power lost. This is the power loss due to convection. Power loss. And percentage of power loss, so we can say power lost upon bulb power into 100 will be the percentage. So it will be 17.33% power loss. Percentage loss is equal to 17.33. Isn't it? 17.33%. Again, option A is the correct answer. Is this clear to everyone? I will share the PDF of this session to my Telegram group. You can try these questions again. Next 3 questions, 3, 4, 5 are common data question. And the common data is given here. What is the data given? Hot air enters with a mass flow rate of 0.05 kg per second through an uninsulated sheet metal duct of diameter 0.15 meter and a length of 5 meter at 103. So the air is entering at 103 degrees Celsius. This is, let us say, pipe. Air is entering. This is the inlet, that is 1. This is the outlet, that is 2. Air is entering, so the bulk temperature of air entering into the pipe is 103 degrees Celsius, TB1, the bulk temperature at the inlet, and at the exit the air cools to 77 degrees Celsius. This is TB2, 77 degrees Celsius. Air is flowing because the temperature is decreasing. So do you agree the heat is leaving from the pipe? There is a heat loss from the pipe. Then only the temperature of air is decreasing from inlet to outlet. the heat transfer coefficient between the duct outer surface, this is the outer surface of the duct, and the ambient air at T infinity. T infinity is the outside air. Here the air is 0 degrees Celsius, is H naught is 6 watt per meter square Kelvin. The specific heat for air is 1010 joule per kg Kelvin. Calculate the heat loss from the duct over the length L. Can you calculate the heat loss from the air? So if we apply the energy conservation equation, if we write the energy conservation equation for this, according to energy equation, what we can say, Q in for the fluid, we are applying the energy conservation for the air. Air is our system. Q in plus Q generated is equal to Q out plus Q stored. That is the basic energy conservation equation. There is no heat entering into the pipe because the temperature of the air is decreasing from inlet to outlet. The heat is only leaving. There is no generation of the heat. So we can say Q out, the heat leaving, is equal to minus Q stored. What is the negative Q storage? That is the decrease in internal energy of air. There is a decrease in internal energy. So Q out is equal to mass flow rate into Cp into Tb1 minus Tb2. That is the heat lost by the air. The heat loss from the duct over the length L. Do you agree? So negative heat storage means the decrease in internal energy of air. And how to calculate the decrease in internal energy? That is mc delta T. If you put the value, mass flow rate is 0.05, Pp is 1010, and the temperature difference of air from inlet to outlet is 103 minus 77. That will give you the answer for first part. That will give you the answer for first part. Is this clear? Energy conservation equation between inlet and outlet. The energy conservation equation between inlet and outlet of the duct. At inlet, the air temperature is Tb1, that is the average temperature of air. The air temperature will have a profile. There is a temperature profile at any section. We all know. Because of the boundary layer growth, there is a temperature profile developed here. So we are talking about the average temperature of air at the entrance, that is 103, that is called as bulk mean temperature of air at inlet, and at the outlet the temperature of air is 77. So the change in temperature of air between inlet and outlet is delta T. Mass flow rate of air is also given, and Cp for air is given. That will give you the change in internal energy of air per unit time. That is equal to the amount of heat lost from the air or the duct per unit time. I hope it is clear. That is how the energy conservation equation is applicable. The answer to the question is option A, 1313. Are you guys getting 1313 what? You will put all the given parameter in their SI unit, you will definitely get the answer in its SI unit. The next question is, if the inside convection heat transfer coefficient, that means the convective heat transfer coefficient of inside air, that is for inside air. There are two airs. In the pipe there is an air flowing and outside is ambient air, and ambient air is at 0 degrees Celsius, and the convective heat transfer coefficient is 6 watt per meter square Kelvin, that is given. Now the inside convection heat transfer coefficient at x is equal to L, this is 0.2, this is 0.1, is given as 11.6. So H2 is given as 11.6 watt per meter square Kelvin. Determine the heat flux at x is equal to L. X is equal to L means outlet. We need to find out Q2 dash at outlet. If we draw the diagram for the outlet will look like this. The outlet, that is 0.2. So here at the outlet the temperature of the fluid is 77 degrees Celsius. There is a duct material or duct thickness. I am drawing the outlet. This is the outlet. This is 0.2. The mean temperature of the fluid is 77, and there is a, and here outside air is having H0 is 6. H2 is equal to 11.6. If we draw the circuit diagram, T infinity is equal to 0 degree Celsius. If we draw the circuit diagram between 2 and outside, so there are two thermal resistance. The material of the duct is, the thickness of the duct is negligible. The thickness of the duct or the thickness of the pipe is negligible. So there are two thermal resistances. One up is 1 upon H2 into area, and another is 1 upon H0 into area. This is 77 degrees Celsius and this is 0. Do you agree or not? If we want to find out Q dash, that is Q by A. So we can say that is delta T upon, what we can say, 77 minus 0 upon 1 upon H2 plus 1 upon H0. Is this clear or not? That will give you the answer. That is Q dash at point 2 at the outlet. That will be Q dash at point 2. At the outlet, what we are doing is we are observing the outlet only. The inner fluid temperature at outlet is 77. The thickness of the pipe is negligible, so there is no conductive resistance, and outside air temperature is 0 degrees Celsius. So we know the inner fluid temperature and outside air temperature. So there is a convective thermal resistance 1 upon HA, and there is outside thermal resistance, outer convective thermal resistance, that is 1 upon H0 into A. We want to find out the heat flux. That will be the answer. What is the answer? 77 divided by 1 upon H2. H2 is 11.6 and H0 is 6 watt per meter square Kelvin. Put the values, you will get the answer. Option A. A will be the answer. One more part of the same question. Determine the duct surface temperature at X is equal to L. Again, outlet. At the outlet, what is the duct surface temperature? If I show you the outlet once again. This is TB2. This is T infinity. The question is to find out TS2. How to find out TS2? If we draw circuit diagram, this is TB2, that is TS2, and this is T infinity. So TS2 can be, so Q dash at 2 is equal to, we can either write H2 into TB2 minus TS2, or we can write it as H0 into TS2 minus T infinity, isn't it? That remains constant. Either calculate TS2 by using this expression Q dash 2 we have already calculated, or you can use this expression. That is your choice. What is Q dash? That is 304.5. So 304.5 watt per meter square is equal to H2 is 11.6, TB2 is 77 minus TS2 is equal to H0 is, what is H0? H0 is 6. TS2 is unknown minus 0. This will give you the value of TS2. Find out the value of TS2. What should be the value of TS2? Are you guys getting option A or not? 50.7. Are you getting 50.75? Yes, Bhavya, 50.75. Very nice. Sachin, good. What about others? The next question, question number 6. The next question on the screen. A steam pipe having an outside diameter 70 mm, surface temperature 200 degrees Celsius, surface temperature is 200 degrees, and emissivity is 0.8, passes through a room in which air and wall are at 25 degrees Celsius. The air temperature and the wall temperature is 25 degrees. if the coefficient associated with the free convection heat transfer from the surface to the air, it is an example of free convection. Outside there is a free convection, from the pipe there is a free convection. It is moving in air, it is kept in an air, it is kept in a room like this. This is the pipe, steam pipe. Now, if the coefficient associated with free convection is 15, then what percentage of heat is lost by convection of total heat loss from the pipe? So there are two modes of heat loss. One is the free convection and another is the radiation. The heat will loss through the radiation as well. So if I write Q convection, then it will be AH into area, surface area, that is pi dl into delta T, that is 200 minus 25, that is Q convection. For length, if we take LS, H is given, diameter is also given 70 mm, H is 15 into pi into diameter 70 mm 0.07 into L 200 minus 25 175, that is Q convection. So what is the heat loss due to convection? Are you getting 577.27? L, what if for L is equal to 1 meter, take L is equal to 1 meter. L will not be required because L will get cancelled out because we need to find out the ratio. For L is equal to 1 meter, it will be 577.27 watt. And what about Q radiation? Q radiation will be epsilon into sigma into area available for radiation into Ts to the power 4 minus T. That will give you the amount of radiation transfer. Epsilon is emissivity is 0.8 into sigma 5.67 into 10 to the power minus 8. Area is again pi into 0.07 into 1 into Ts to the power 4. The temperature must be absolute temperatures here. So what is the absolute temperature of the fluid or absolute temperature of the pipe? 200 plus 273, 473. So it will be 473 to the power 4 minus 25 plus 273, 298. What is 25 plus 273, 298 to the power 4. You will do the calculation. You will get Q radiation. What is the value of heat loss through the radiation? Yes, you could have considered the flux. This area will be same in convection and radiation. The area will be same. So no need to, because we are supposed to find out the ratio. Then no need to take the area. Convection and radiation both are surface phenomena. So in both the analysis or in both the equation, we need to use the surface area available for convection and radiation. So the area will remain same. Yes, you can keep the analysis simple by ignoring the area also. Q radiation, considering the area, Q radiation is 420.6. That is Q radiation. So Q convection divided by Q total, that is convection plus radiation, into 100 will be how much? It will give you the value 577.27 divided by 577.27 plus 420 into 100. That will be the answer. Can you solve it? What will be the answer? What will be the answer? Are you getting 57.8? B. Are you getting 57.8 or not? The next question, question number 7. A wire of 1.5 mm diameter. The next question. Read the next one and try to solve it. A wire of 1.55 mm diameter and 200 mm long is submerged in water. Is submerged in water to boil at 100 degrees Celsius. So the fluid temperature or the water temperature is supposed to be 100 degrees Celsius. Water temperature is 100 degrees Celsius. How much electrical power must be supplied to the wire to maintain the wire surface at 130 degrees Celsius? The surface temperature of wire is supposed to be 130 degrees Celsius. If the convective heat transfer coefficient is 3275, very simple question. This question is very simple. Sachin, what is that? The answer to previous question or this one? So how much power is supplied? So we need to find out Q supplied. The mode of heat transfer will be convection. There is a convection. So the power supplied will be the power supplied, Q supplied from the energy conservation equation. Q supplied is equal to Q loss. And the heat is lost due to convection. The amount of power supplied should be equal to Q in is equal to Q out. Because there is no heat stored in the wire. It is in steady state. There is no heat generation in the wire. So we can say the power supplied is equal to heat loss. So that is H into area. Area of the wire is pi dl. Because the diameter is very less compared to the length. So the area can be taken as pi dl only. The diameter is 1.5 compared to 200. Into delta T, that is 130 minus 100. Will give you the answer. Sachin, 200 to galat hai. 200 is not correct. You are calculating Q dash. Are you calculating flux? If you will put the value, the convective heat transfer coefficient is 3275 into pi into diameter, that is 1.5 into 10 to the power minus 3 into 0.2 into 130 minus 100, that is 30, will give you the answer. That is Q supplied will be 92.6 watt. Are you getting 92.6 watt? Option A will be correct. Now I want you guys to give me the answer for this one, question number 8. I want you to solve this question and let me know. A fluid's thermal diffusivity alpha. What is the unit of thermal diffusivity? Meter square per second, same as kinematic viscosity or momentum diffusivity. Prandtl number is unitless and density E are given. Density is given by E. The dynamic viscosity of the fluid, that is mu, is expressed in terms of these quantities. The unit of dynamic viscosity is Pascal second or Newton second per meter square. You can check the units also to get your answer. You can check the units to get your answer, or you can what is the correct answer? Yes, Bhavya. I want everyone to give me the answer. This is the connection between fluid mechanics and heat transfer actually. The question is containing the concept of fluid mechanics as well as the heat transfer. So mu is kinematic viscosity is dynamic viscosity per unit density. So the dynamic viscosity is rho into kinematic viscosity, and another relationship is there, that is equation number 1. Prandtl number is equal to the ratio of kinematic viscosity to the moment to the thermal diffusivity. The Prandtl number is the ratio of kinematic viscosity to thermal diffusivity. So from here kinematic viscosity is Prandtl number into alpha. You put the value in equation number 1. So mu is equal to rho into Prandtl number into alpha, isn't it? Isn't it? The product of all the three, alpha into Prandtl number into density, isn't it? It is the product of all. So there are three dimensionless numbers which are properties. Do you know that? Based on these three parameters. One is momentum diffusivity. The unit is meter square per second. Another is thermal diffusivity, and one more is mass diffusivity. So the ratio Prandtl number is the ratio of kinematic viscosity by alpha. Then Levi's number is the ratio of alpha by d, and Schmidt number is the ratio of kinematic viscosity by d. These are dimensionless numbers which are the properties. These are the dimensionless numbers which are also the property of the fluid. Question number 9. Couple of more questions before we end the session. A vertical metallic wall is resting in air at 91 degrees Celsius. The wall temperature is 91 degrees Celsius, so the surface temperature is 91 degrees Celsius, and the temperature of the wall, air at 91 degrees Celsius, so the air temperature is 91, and the surface temperature of the wall is 159 degrees, right? The air temperature or T infinity is 91 degrees. If the properties of air at the film temperature are kinematic viscosity, thermal conductivity, Prandtl number, and momentum diffusivity are given, and if Nusselt number is given by this expression, it is the natural convection. It is an example of natural convection. Ra is the Rayleigh number. What is Rayleigh number? Do you know what is Rayleigh number? That is the product of Grashof number into Prandtl number. So the Rayleigh number and the Nusselt number are, take the height as 80 centimeter, or we can call it as characteristic length L, because the boundary layer is allowed to grow over this length. So L is equal to 80 centimeter or 0.8. You need to find out the Rayleigh number and Nusselt number. So how to find out the Rayleigh number? Prandtl number is given. We need to find out the Grashof number. What is the formula for Grashof number? Do you remember? Rho square G beta delta T L cube by mu square. Or we can write mu square by rho square is kinematic viscosity square. So G beta will be equal to 1 upon T into delta T into L cube by kinematic viscosity square. If you put the value, Grashof number will be calculated first. 9.81 into delta T is 159 minus 91 into L cube 0.8 cube upon film temperature. What is the film temperature? That is 159. Film temperature will be equal to 159 plus 91 divided by 2. How much is that? 160 plus 90, 250 by 2. 125 degrees Celsius. But we need to take in Kelvin. The unit of beta is 1 by T Kelvin inverse. The temperature has to be in Kelvin. It is 125 plus 273 into kinematic viscosity square. That is, what is the kinematic viscosity? 25 into 10 to the power minus 6. 25 into 10 to the power minus 6 square. First of all, let me know the value of Grashof number. Once you get the value of Grashof number correctly, then you will be able to get the Rayleigh number correctly. What is the value of Grashof number? What is the value of Grashof number? 1.37 into 10 to the power 9. That is the value of Grashof number. And what is the Rayleigh number? That is 1.37 into 10 to the power 9 multiplied by 0.7. That will be the Rayleigh number. Grashof number into Prandtl number is Rayleigh number. So if you multiply with 0.7, What is that? It will be 9.61 into 10 to the power 8, isn't it? 9.61 into 10 to the power 8, that is the Rayleigh number. Are you getting Rayleigh number? 0.7 is the Prandtl number. So Grashof number multiplied by Prandtl number is the Rayleigh number. So it is the laminar motion. This equation is for laminar. This equation is for laminar motion, isn't it? Are you getting? Beta is 1 by T. For an ideal gas, beta is 1 by T. What is beta? Coefficient of thermal expansion. And for an ideal gas, it is reciprocal of temperature. तो मैंने film temperature 1 by film temperature लिखा है. And film temperature is 125 degrees Celsius. Film temperature. And if we convert it into Kelvin, 125 plus 273, this is beta. This is beta. आपका आंसर कैसे मैच कर गया ग्रासोफ नंबर का भव्या? सही तो है? क्लियर? डिनोमिनेटर में 125 प्लस 273 आएगा. बीटा इज 1 अपॉन फिल्म टेम्परेचर. फॉर एन एयर कैन बी ट्रीटेड एज एन आइडियल गैस. Are you getting this? Rayleigh number. And what is Nusselt number? Use the expression for laminar motion. $15 तो ये है. अच्छा 15 क्या लिखा मैंने? अच्छा 15 कैसे लिखा? नहीं ये गलत लिखा. ये गलत लिख दिया ना. मेरे को भी नहीं ध्यान 15 लिखा कहां से मैंने. क्या चीज है? Okay, forget about this 15. This is how you will get the Rayleigh number, and Nusselt number is equal to 0.6 into 9.61 into 10 to the power 8 to the power 0.25. That will give you the Nusselt number. What is the Nusselt number? Are you getting 105.4? 105.4? Are you getting Nusselt number as 105.4? So whatever the option is nearest, the Rayleigh number is 9 into 10 to the power 8. This is not true. This is not correct. And the Nusselt number is around 104 or 105.64. Option C is more appropriate. Option C is the most close option. That is the correct answer. Do you know for natural convection? For natural convection, you need to remember couple of formula. If the flow is laminar, if the motion is laminar, when the motion is laminar? When the Grashof number is less than 10 to the power 9. When it is less than 10 to the power 9, then laminar. So Nusselt number is proportional to Rayleigh number to the power 1 by 4. And for turbulent motion, when Grashof number is greater than 10 to the power 9 something, then Nusselt number is proportional to Rayleigh number to the power 1 by 3. And what is Rayleigh number? The Rayleigh number is the product of Grashof number into Prandtl number, where Grashof number is given by rho square beta delta t LC cube by mu. That is how it works. And LC is the characteristic length, the length over which the boundary layer is allowed to grow. The length over which the boundary layer is allowed to grow. That is for natural convection, right? Question number 10. Question number 10. For a fully developed laminar flow for a fluid flowing through a tube. Laminar flow, internal flow. It is flow through a tube, internal, of 8 mm in diameter under uniform wall temperature boundary conditions. The Nusselt number is 3.66. You should know for internal flow. For an internal flow, if the flow is laminar, when do we have the laminar flow? When the Reynolds number is less than 2000. Then the Nusselt number is constant. The value of constant is 4.36. If flux is constant, Q dash is constant. The value of Nusselt number is 4.36. The value of Nusselt number is 4.36 if Q dash is constant, and it will be 3.66 if TS is constant. And for turbulent boundary layer, for turbulent flow, when the Reynolds number is greater than 4000, then Nusselt number is proportional to Reynolds number to the power 4 by 5 into Prandtl number to the power. The expression is similar to external flow. These are important relations for internal flow. Now the tube diameter is 8 mm and uniform wall temperature condition. That is why the Nusselt number is 3.66. The thermal conductivity of the fluid is 0.2 watt per meter Kelvin. If the mean temperature difference between the wall and the fluid, that is delta T, is equal to 40 degrees Celsius, the per meter heat transfer rate for length is equal to 1 meter. The rate of heat transfer between the fluid and the wall. So Q, the mode of heat transfer will be convection, that is H into area pi dl into delta T. Delta T is given, diameter is given, L should be taken as 1 meter. We need to find out H. From where? From using the Nusselt number. So first of all, find out H. The Nusselt number, that is H into D by Kf, is equal to 3.66. From here, we need to find out the value of H. What is the value of H? Are you getting 91.5 watt per meter square Kelvin? H, and then Q is equal to 91.5 into pi into diameter is 8 mm, so it will be 0.008 into 1 into delta T. 40 will be the answer. What is the answer? Are you getting 92 watt or not? Around 92. 91.98. Yes, 91.98, almost 92. D is the right answer for question number 10. The next one, the critical value of, very simple question, the critical value of Grashof number in natural convection and the critical value of Reynolds number. What is critical? When the flow changes from laminar to turbulent. The moment when the flow changes from laminar to turbulent, that is called as critical. And Grashof number decides the nature of fluid motion in case of natural convection, and the Reynolds number decides the nature of fluid flow in case of forced convection. So for flow over a flat plate, that is external flow. For flow over a flat surface, respectively are. For external flow, our critical value of Reynolds number is 5 into 10 to the power 5. So B cannot be correct. First is Grashof number, second is Reynolds number. This is also incorrect. For internal flow, this is for internal flow. 2300 is applicable for internal flow. So B and D cannot be true. So 5 into 10 to the power 5 is Reynolds number. And what is the Grashof number? Is less than 10 to the power 9 something. 4 into 10 to the power 8. This is not correct. C is not correct. Option A is more appropriate. Hi Yogesh. Good evening. Welcome. How are you? Option A is the answer, isn't it? 4 into 10 to the power 8 for flow for natural convection over the flat surface. Question number 12. Question number 12. There are two pipes. In the first pipe, water at 80 degrees Celsius is flowing and its wall is at 105. There are two pipes. It means internal flow. Flow in a pipe. In the first pipe, water at 80 degrees Celsius and wall is 105. So delta T is equal to Ts minus T fluid. That is the temperature difference. That is 105 minus 80. The surface heat transfer coefficient for this pipe is 600. H1, this is delta T1. H1 is equal to 600 watt per meter square Kelvin. In the second pipe, water is at 50 and wall temperature is 95. Delta T2 is equal to 95 minus 50 degrees Celsius, and the convective heat transfer coefficient H2 is 800. Question is very simple. You need to find out the ratio of heat flux of first and second pipe. What is heat flux? Q by area. That is equal to H into delta T. So we can say Q1 dash upon Q2 dash is equal to H1 by H2 into delta T1 by delta T2. That will give you the answer. H1 is 600 by 800. Delta T1 is 105 minus 80 upon 95 minus 50. That will give you the answer. This is the ratio. It is option A. Option A is the right answer. And one more question, question number 13. Another question. Can you let me know the answer? The last question for the day. Can you let me know the answer to this one? The thermal boundary layer thickness and hydrodynamic boundary layer thickness are related through X number, dimensionless number X, while Peclet number is the product of Prandtl number and Y. You should understand. You should understand the significance and the formula for various dimensionless numbers. So for laminar motion or laminar flow over a flat surface, delta X, the velocity boundary layer thickness upon thermal boundary layer thickness, is given by Prandtl number to the power 1 by. So delta V and delta T are connected with the Prandtl number. The thermal boundary layer thickness and hydrodynamic boundary layer thickness are related through X number. That is the Prandtl number. So X is Prandtl number. X will be Prandtl number. C cannot be correct. D cannot be correct. Prandtl number. And Peclet number. Do you know what is Peclet number? What is Peclet number? Peclet number is the product of Reynolds number and Prandtl number. The way Rayleigh number is defined as the product of Grashof number into Prandtl number, that is Rayleigh number. In natural convection, it is the Rayleigh number. And Peclet number is the product of Reynolds number and Prandtl number. And one more number is defined, that is called as Stanton number. Do you know what is that? The ratio of Nusselt number divided to the Reynolds number into Prandtl number, or Nusselt number upon Peclet number is Stanton number. The Peclet number is the product of Prandtl number and Y. What is Y? Y is the Reynolds number. Theoretical question. Option A is the right answer. Option A. X is Prandtl number and Y is Reynolds number. So that is all from my side for the day. Please do this assignment question and bring your answer in the next class, or you can share your answer through on my Telegram group, or you can write your answer in the comment section of this session E1. So please please revise the concept of heat exchanger before coming to the next class. That is tomorrow at 6 p.m. we will discuss the beautiful concepts of LMTD approach and NTU approach in heat exchanger. So till then, enjoy, take care, have a good day, and take care. This is my schedule for entire heat transfer. Tomorrow we will be meeting for heat exchanger, and then there will be two more sessions. One is for shape factor of radiation and another is radiation analysis. Right? Again, I am sharing my Telegram group. Those who have not joined me on the Telegram yet can join me on the Telegram, and you can note down my email ID to discuss your doubts with me. With this note, let me take your leave. Stay safe, stay motivated, and keep preparing. Thank you. Enjoy and have a good day and a great future ahead. Jai Hind.